Good afternoon, everyone. I am going to speak on a site named Khanak. Khanak means village of miners, खान वालों का गांव, क्योंकि आज भी वहां जो है माइनिंग चलती है। उसी के लिए ये मेरा पेपर है जिसकी मैंने 2 साल खुदाई कराया। As introduction, I can point out that in 1999, Kocher and Dilip Chakravarti published a paper, a new source of primary tin ore in the Indus civilization, published in South Asian Studies, the Journal of the British Academy, and pointed about the presence of tin ore in that area, in Tosam area, where my site is situated. Although the occurrence of tin in Tosam has been reported in 1982 by Kocher, but its implication in the context of Harappan civilization was not understood at that time. Dr. Narendra Parmar, who is now lecturer in Haryana, did his PhD under Basant Shinde, explored the Bhiwani district extensively and reported a number of sites in Bhiwani in Arauli zone, and Khanak is one of them. In this context, particularly in the context of mining and extraction of minerals in that area, in this context, Randall Law's work is quite important, who has studied the mineral resources and network spawned by the need of Indus city like Mohenjo-daro, and mentioned that the second most common type of grinding stone at Harappa appears to be the type of Delhi quartzite found only in the westernmost outliers of Arauli Mountains. Located in southern Haryana, none of the other geologic formations immediately surrounding the upper Indus basin contain material that even remotely resembles this distinctive type of quartzite. Grinding stone made of this stone at Harappa are easily identified. He has reported that in the Arauli, basically from where this Kalendana bench, where the Khanak is situated, stones are identified at Harappa and Mohenjo-daro, both areas. That's why it means that the Harappans were acquainted with this area in mining and extracting the minerals. In this context, project study is important, showing metallurgical and mining knowledge of Harappan. Discovery of bronze age artifact in Khanak, tin slag, furnaces and crucible together with the geological evidence on the tin deposit in Tosam area of Bhiwani district in Haryana provide the opportunity to survey the evidence of possible sources of tin and the use of bronze in the Harappan site of Northwest India. Afghanistan emerged as the most promising eastern source of tin utilized by Indus civilization, coppersmith. In this context, our excavation conducted at Khanak near Tosam mining area during 2014 and 16 revealed ample evidence of metallurgical activity. Then we have conducted petrological, XRD, EDAX, TEM, SEM, and metallography on the slag ores, crucible fragment, bronze object, and other samples. This has given positive indication of mining and metallurgy of polymetallic tin at this site. In view of the importance of site, we wanted to excavate the site urgently again, but because of the COVID-19, I could not do that. Kocher has mentioned the geology of this area has been well studied by Kocher. Rocks belong to the Malani igneous suite of rocks of western Rajasthan. Quartzite and meta sediment belonging to the Delhi supergroup. The Tosam hill is surrounded by Khanak, Rivasa, Dulheri, Dadam, Dharan ring complexes. The occurrence of primary tin in the form of cassiterite from the Tosam area was first reported by Kocher in 1982, which was found associated with the muscovite biotite granite. He has given this figure about the distribution of tin in the area. About this settlement, a brief about the settlement. Ancient settlement of Khanak is situated in the Tosam block. It lies at a distance of 30 kilometers northwest of Bhiwani and 8 kilometers northwest of Tosam. There are 2 protohistoric sites in the village. The site is located within the boundary of government senior secondary school. You can see in the figure, in the photo, site is in the boundary of the secondary school. The site is just about 100 and 200 meters far from Khanak Khila Barauli. This site is subjected to excavation for 2 seasons by Banaras University in collaboration with Dr. Cameron Petrie of University of Cambridge. You can see already the mining now even today the mining of granite is done in the hilly area, and only 100 meters from there is site. Its location map, it's Google map. Google map indicating these trenches we have undertaken. Purpose of our excavation. Primary objective of proposed small excavation is to assess the cultural material of early Harappan and mature Harappan, context of exploitation of stone and minerals, context of tin and its mining in this region of Arauli, to obtain datable material for radiometric dating, to collect different geological and mining samples for provenance study, to collect archaeobotanical and archaeogeological materials, to collect soil samples for phytolith study and vessel dating, to construct furnace and mining activities at the site, and to explore ancient mining area in the vicinity. In this context, I can mention that that geological study is being done by P.P. Joglekar, sir, and botanical studies are being undertaken by Jennifer Bates, and geological studies is being done by Tantani Niyogi in Cambridge. And other things we are already doing. Radiocarbon dating has been done by Oxford Laboratory through Cameron Petrie. I will show the dates. During our excavation in 2016, 16 trenches were laid down from A to 16, including in previously excavated A1 trench, which we have excavated in 2014, and we did again it. In addition, a section cutting trench B01 was also exposed quite near to Khanak Hills in the area of recent mining. A site plan was also prepared utilizing total station survey supplied by University of Cambridge. All trenches except A5 were quite productive, having early and mature Harappan cultural materials. A5 was a recent filling by through labeling of the school ground. In order to assess the extension of the site, a section was exposed quite close to the Khanak Hills in recent mining area, named as Trench B01, which was also quite productive, having both early and mature Harappan cultural material, suggesting a cluster of other settlements at different places in entire Khanak village. Maximum cultural deposits were 2.65 meter. This is the contour plan prepared by Cameron Petrie, which is similar to the Google map. We have required about 6 room complex, a small room trench 1 to 16. The size is given in the site. Width of walls are 0.30 meter. There is another structure of mature Harappan period, but only one wall was preserved. Other walls were removed by subsequent settler. Considering the cultural material associated with this structure, it seems that these rooms were utilized by craftsmen engaged in metallurgical operation. We have got another stone wall. We could not get other end of this area, this trench, this wall, but probably it was a stone wall. There was a pit in A3 of early Harappan period, and this pit was full of ice. We have selected sample for radiocarbon from this area. There is another earth or maybe furnace, much detail about this. This is a section of this section cutting trench just near the hilly area and the vicinity of hilly area, showing early Harappan to mature Harappan material. This is another trench. Here also we have got material from early Harappan to mature Harappan. No late material is in the site. During our excavation in second season, an appreciable range of cultural material were recovered belonging to early Harappan and mature Harappan, confirming the sequence of our earlier excavation published in Indian Archaeology Review 2013, 14, and 15, 16. The most common material recovered was fragments of fired ceramic vessels of various types. We have counted the number. Among the antiquity, statiite beads figured highest in number, 487, but there were also a range of other small findings, including TC cake. It's also quite high. Idli shaped rectangular, 2,331, mostly broken. Beads of semi-precious stone, including lapis lazuli, carnelian, agate, jasper, stone bead, pieces of TC bangles, and 2 fragmentary TC animal figurines. In addition, excavation revealed several pieces of crucible along with large number of slag, ashes showing metallurgical activity in the vicinity. Here is the example of statiite bead, lapis lazuli, and carnelian bead. This is other antiquity, the TC bead, TC bangle, ball, and few pieces of blade. Pottery. Potteries were largely wheel-made with few handmade as well. The main ceramic assemblage include mud applique ware, exterior incised ware, chocolate silverware, interior incised skirt, bearing typical shapes such as flat top bowl, basin, disc base of vase, beaded rim vase, perforated jar, dish on stand, goblets, handled vessel, and a handmade spout, a spouted part, perhaps milk feeding, for milk feeding vases, leg bowl goblet, handle, miniature parts, etc. Most characteristic part is the dull ware with painted decoration in 2 colors, bichrome akin to Kudal type, a few with people leaf impression also, people leaf depiction also. Inside design include group of parallel bands, chevron, herringbone pattern, crisscross, short stroke, nail, and thick wavy lines, etc. A good firing, soothing, and mud application. Ceramic suggest cultural deposits from perhaps pre-early Harappan, and mature Harappan. There are some example of pottery reported from the site, recovered from the site, perforated jar, few shape vases, dish on stand, footed and few shape of painted potteries. We have also got potteries with post-firing soothing and bichrome parts with people leaf decoration, and also some potteries are having graffiti mark, resembling to the other sites of Harappan. Regarding dating, we have got 3 dates from radiocarbon date from Khanak. It is done with the courtesy of Dr. Cameron Petrie from Oxford. Our sample from Khanak ranges from 3000 BC to 2200 BC. From means it's the early Harappan to mature Harappan only, no later material is present. Now coming to the analysis part. Since we could not do the analysis of ore from that area, we have collected reference from the literature, and Munro et al. Have conducted PIXC, proton probe analysis on the polymetallic tin ore from Tosam area. They have concluded that Tosam deposit in Bhiwani district, Haryana, India is of new age and contains SEM-CU prospect. It is inferred that rockisite and stenite in the Tosam ores coexisting with the chalcopyrite. Some of the analysis analyzed stenite grains in Tosam ores could possibly be petrokite. Analytical data of Tosam ore and Jedian CuFe in S ratio are represented below. In addition, PIXA studies on Tosam areas also represented. These data are highly valuable for the study of tin metallurgy in the area by comparing data without sample. This I have taken to compare with our analysis to confirm if our material is from local sources or from other sources. Analytical study: 11 samples including 5 fragments of crucible, 4 slag, 2 samples of copper, celt, and one sample of melt adhered to a potsherd were examined by SEM-EDS technique at the Central Instrumentation Facility in the IIT BHU. Quite a small amount of samples were chipped up from the crucible fragment and from the melt adhered to the potsherd, while samples were taken from the copper celt by drilling. This is the description of 11 sample which we have examined. It's from mature Harappan and early Harappan both period. And depth and layer is already given. This is the samples we have analyzed. 5 samples from top is the crucible, 6 sample, and 2 sample is from slag. This last corner sample is a pottery where the melted tin is adhered. And last one is copper celt. Everyone can recognize it. SEM-EDS analysis. The sample from 1 to 10 were analyzed by sigma GIS scanning electron microscopy using an Oxford instrument. The areas analyzed were conducted by energy EDAX with detection limit of about 0.3 weight% at the Central Instrumentation Facility, IIT BHU. For the analysis of crucible and melt on the potsherd, the goal was to average over the largest area possible while avoiding large voids. Oxidized area in the case of slag, unmelted included. Parameters of spectrum processing for EDS is given in the box. This is the result of slag and copper celt from Khanak. You can see a red line is given as percentage of tin, weight percentage of tin in the sample. You can see it ranges from 18.4, but all the samples are having tin. In slag and even in copper celt, it's quite low because it's already it's low tin branches. Copper celt we have copper celt we have only 2 samples. It's 2% and 0.34%. But still there is tin present in the copper celt sample. And regarding crucible, in the crucible and melt up and the melt on the potsherd, you can see the red line is depicting. Red line is given as the percentage of the tin, ranging from 13, 14, somewhere it's 18. At some area in melted part, it's 1.82. Other area, because in the scanning we have to move the cursor to detect the particular area. It depends upon in the same sample, the percentage may be different from time to time. This is SEM image and peak of spectrum obtained from EDS of slag. You can see certainly in the slag silica will be higher, but still tin is present there. SN is already given. Similarly, in the crucible, here we are getting lead also, and tin also may be present as the impurity in that particular crucible. This is the SEM image and peak of spectrum of EDS of melt and pottery. Here also we have got 2 spectrum related to tin. And finally, copper celt. Here, peak of tin is quite low. It's obvious because the percentage of tin was, as shown in the composition chart, it's quite low. Result and discussion. Our analysis indicate an acceptable degree of agreement between the concentration of major element in slag, fragment of crucible, determined by PIXA, SEM-EDS, and the ones obtained by proton probe and PIXA analysis of somewhere, ores conducted by Murao. We have compared data with the Murao's ore result, and almost they are similar. Our SEM-EDS analysis demonstrated that there are sufficient amount of tin in sample of the slag, melt and crucible, and potsherd. 5 slag samples analyzed by us contain tin, as KNK S2 10.72%, KNK S4 11.21%, KNK S3 13.31%, and KNK S1 18.49% in weight percentage. Similarly, melt adhered to crucible 5 sample and potsherd shows the weight percentage: tin as 13.51, 18.59, 2.40, 17.20, 19.14, and 9.50. Harappan recovered from Khanak is also subjected to SEM-EDS. Analysis gave 2.02%, showing low tin branch, and which is the indication of positive indication of tin metallurgy at Khanak. Finally, data emerged so far from the present and earlier analysis and subsequent petrological SEM-EDS and EDAX studies revealed that the Harappan settlers at Khanak utilized locally available polymetallic tin ores from nearby areas. Although the data obtained so far are the certain indication of tin metallurgy in the area, particularly at Khanak during Harappan period, but the quantum of the extractive metal is yet to be assessed. It can be surmised that the settlers of Harappan, Northwest India, were utilizing these sources for tin extraction, while other major centers such as Mohenjo-daro, Harappa should have utilized tin sources in Afghanistan. However, further fieldwork in this area is required to explore more settlements in order to assess the potential of the metallurgical practices, supplemented by detailed scientific examination of the crucible lining, furnace lining, slag, copper celt, and other materials. Scientific studies of Khanak materials are still going on, which may more light in the status of research of mining in this area. Thank you.